Welcome! In this video, we explore case studies of numerical model applications in active orogenic belts. We will see how coupling tectonics, climate, and surface processes explains real mountain belts. We will visit the Himalaya, the Andes, the Southern Alps of New Zealand, Taiwan, and briefly three more examples. First, the Himalayan Tibetan orogen. Channel flow models propose that a low-viscosity, partially molten mid-crustal channel can flow outward and be extruded along the range front if erosion is intense. We will draw a simplified cross-section and then add rainfall and flow vectors to see the coupled behavior. As erosion removes material at the front, the channel is drawn outward, exhuming high-grade rocks and producing inverted metamorphic sequences. Coupled models further show that in mature stages, uplift and erosion can correlate strongly, close to 0.9, and topography develops two steps, matching the lesser and greater Himalaya. Next, the Andes, an ocean continent subduction orogen, with a dramatic along strike climate gradient. Models show that colder, stronger lithosphere and very weak erosion in the south funnel deformation into a narrow, steep belt. In contrast, in the central Andes, slightly weaker lithosphere and more erosion distribute shortening, forming a wider plateau. We will compare a narrow, dry end member with a wider plateau case. Coupled models also find a lower correlation between uplift and erosion in the dry regime, suggesting a more tectonic-dominated state. Third, the Southern Alps of New Zealand, a compact, obliquely convergent mountain belt with extreme rainfall on the western side. Models show that orographic precipitation focuses erosion, which feeds back on stress and localizes uplift and exhumation beneath the rain maximum. We will draw a single fault-bounded range with rainfall on the west, and then highlight the exhumation bowls under the wet flank. Fourth, Taiwan, a youthful arc continent collision with rapid shortening and very fast erosion. Thrust wedge models indicate the wedge stays near a critical taper, even as storms spike erosion. We will draw a simple wedge, add a typhoon symbol, and indicate the balance between rock uplift and erosion flux. Finally, three quick examples. Western Alps, glacial erosion limits peak heights, a glacial buzzsaw effect. Apennines, lower erosion can allow over-thickened belts to collapse internally. Zagros, weak salt layers localize broad folds and hidden duplexes. These case studies show that numerical models are unifying tools. By tuning rheology, convergence, rainfall, and surface processes, we can reproduce observed topography, exhumation, and basin evolution and test what-if scenarios. As data and computing improve, models will keep sharpening our understanding of Earth's mountain belts.